Next up, we have geometric progressions. And like arithmetic progressions, it's a sequence of numbers. But this time, instead of differing by a constant number where you add it, it is differing by a constant multiplier. And that multiplier is called the common ratio. For example, this sequence right here, 2, 4, 8, 16, 32. To get from one term to the next, what we need to do is multiply by 2, and so on. Therefore, that 2 is going to be your common ratio. We call that common ratio R, so R equals 2. To get a general representation of the geometric progression, we can use again the first term being A, and every term after that being represented by A and R. So multiply that A by R, we get AR, which is the second term. Multiply that by R again, we get AR squared, which is the third term, and so on. Remember, the term 1 meaning n equals 1, term 2 meaning n equals 2, and so on. N equals 3. And now for term n, where n equals n, we are going to get a general formula which is going to look like AR power n minus 1. Like this one. For term 5, when n equals 5, we have AR power 5 minus 1, which is AR power 4. Right, where A is the first term and R is the common ratio. Next, the fifth term of a geometric progression is 1. Therefore, when n equals 5, the nth term equals 1. And the common ratio is a half. R equals to 1 over 2. Find the 8th term. So when n equals 5, what's the nth term? Right? And the expression of that nth term as well, using this right here. So for this, we need the A. We can get the A from this information right here, where we have that the nth term, which is 1, is equal to A times R, which is a half, times n minus 1, which is 5 in this case, so 5 minus 1, which is just 4. So we get that 1 is equal to A times 1 over 16. Multiply by 16 on both sides, we get that A equals to 16. Then with that A equals 16, we can find the 8th term, n equals 8, sorry. So we will get 16 times a half power 7, because 8 minus 1. And here we will get 16 times 1 over 128. And here we will get 1 over 8 as our answer for our 8th term. This is going to be our 8th term right here. Then to find a general expression of the nth term, we will just have our A, which is 16, times a half, which is our R, power n minus 1. And that's going to be the general nth term right here. Next, the second and fifth terms in the geometric progression are 12 and 40.5 respectively. So second term, which is represented by AR, because AR power 2 minus 1, which is AR power 1, is equal to 12, and AR power 4 from 5 minus 1 is 40.5. And we need to find our first term and the common ratio. Again, two equations, both have A and R. We solve it simultaneously. Obviously, we cannot use elimination, as we said in our first class of quadratics. Nonlinear equations can be only solved using substitution. So we can substitute A or R. Let's just substitute A in this. So make A the subject. So A equals 12 over R. And we're going to put that into A right here. So 12 over R times R power 4 equals 40.5. Which will be 12 R power 3 equals 40.5. Over 12 over 12, we get that R cubed equals to 3.375. Then take the cube root of R here. We will get that R is equal to 1.5. That's going to be our common ratio. And our first term, we can find from this right here. A equals to 12 over 1.5. We will get that A equals to 8. And with that, we can get our nth term expression, which is going to be 8 times 1.5 power n minus 1 to give you the nth term right here. Next, the nth term of a geometric progression is 9 times negative 2 over 3 power n. And remember, generally, the nth term is like this, AR power n minus 1. Now, let's rewrite this so that we get the power of n instead of n minus 1. For that, we need to go back to our exponent laws, where remember, R power n over R is equal to R power n minus 1. Therefore, if we want to represent this in a different way where we want R power n, we will use this thing right here. r power n over r. So we can write this as a r power n over r, and that should be the same as 9 negative 2 over 3 power n. From that we will get that negative 2 over 3 power n, we can compare it to r power n. So r will equal to negative 2 over 3. And with that we can also find our a using this comparison. A over r equals to 9. So a over negative 2 over 3 equals to 9. And from that we get that a equals to negative 6. So a is negative 6 while r is negative 2 over 3. Next, we can derive the formula for the sum of a geometric progression. So just like we did the sum of the arithmetic progression, which is derived by Gauss, we can also derive the sum of the geometric progression. And the way we do that is take our original progression, which is Sn, where you just add the terms, which is what you want to find, and you bring up another progression where you multiply the Sn by r. So Rsn will equal to ar plus ar squared plus ar cubed plus so on, ar power n minus 1 plus ar power n, because we're multiplying by r. So this last term will also multiply by r. Therefore, our last term is going to be ar itself. And then we can subtract them. And what will happen is all of these will cancel out. And we will be left with Sn minus Rsn is equal to a minus ar power n. Well, what we can do here, factorize Sn on the left, factorize a on the right. We end up getting Sn 1 minus r equals to a 1 minus r power n. And remember, we wanted to find Sn, which to make this the subject, we just divide by 1 minus r, we divide by 1 minus r. And that will give us the formula of the sum of the geometric progression, where Sn equals to a 1 minus r power n over 1 minus r. And that's going to give us the sum of the geometric progression formula. Now, let's use it a few times. Find the sum of the first 12 terms. So we want to find S12. And for that, we need to do a times 1 minus r power 12 over 1 minus r. So we need our first term, which in this case is 3. And we need our r, which in this case we can find. To get from the first term to the next, we will multiply by 2. And then next to the third, multiply by 2 and so on. Therefore, our r equals 2. So 3, 1 minus 2 power 12 over 1 minus 2. This will give us negative 12, 285 over negative 1, which is going to equal to 12, 285. And this is going to be the sum of the first 12 terms in that geometric series. Next, final example. The third term of a geometric progression is 9 times the first term. Therefore, the third term, which is ar power 3 minus 1, which is ar squared, is equal to 9 times the first term, so 9a. Then the sum of the first 6 terms, which is 1 minus r power 6 over 1 minus r, is k times the sum of the first 2 terms. So k times a 1 minus r squared over 1 minus r. And now we have to find the value of k. So first, let's just simplify the right one, because I can see it straight away. 1 minus r, 1 minus r are both on the denominator. We can just remove them. And then we can look at the first one again, where we can remove a. And you basically have r squared equals 9. Therefore, r equals to 3 and r equals to negative 3. Then we have to look at each case differently. So when r equals 3, we have that a 1 minus 3 power 6 is equal to ka 1 minus 3 power 2. From this, a and a can cancel out, and we can compare these two right here. On the left, we'll get negative 728, and on the right, we will get negative 8k. Divide by negative 8 both sides, we will get that k is equal to 91. Then we can use the case of r equals negative 3, where a bracket 1 minus negative 3 power 6 is equal to ka 1 minus negative 3 power 2. This is going to give us the exact same thing. We can cancel out the a's. We will get negative 728 equals to negative 8k over negative 728 over negative 728. We will get that k equals 91. So both cases of R give us that k equals 91.